Good afternoon, everyone, or good morning to people join from West Coast. My name is Jing Yu. I'm the managing director at Fortress Power. So just a little bit of background about myself. I joined solar industry right after I received my electrical engineer degree many years ago in Germany. So I consider myself married to a renewable energy industry, and I truly love what I do. So today we're gathering here to talk about the following topics. So we're going to cover, why should solar companies now offer energy storage to their customers? And then we're going to talk about what's available battery technologies. And then we're going to also do a comparison. At the end, we're going to also focus on how to integrate your energy storage solutions to new and existing PV systems. So we're going to also, talk about different inverter technology as well. So yeah, let's get started. Also, a side note is we will send you the webinar slides after the presentation. And also, if you have a time, you can also in between typing in the question section. And at the end, I will get, those questions answered. Okay, and also just want to make sure that before I start, see if anybody claim that, the sound quality is poor. Looks like there's nobody text that. That's good. So let's take a look at the market trend. Now here's the data collected or projected by GTM Research. So as you can see, that the U.S. energy storage market is, going to grow tremendously, and it's also this year become the #1 market globally. The last 2 years, the revenue doubled, and in next few years, we're still also going to looking to increase another 3 or 4 times. So that's really encouraging. And also, if you look in the breakdown here by segment, which very positive is that the residential and non-residential, basically, nonprofits and commercial is going to constitute over 50% of market share. And that's why, a lot of small and medium-sized contractors going to focus on those segments. Now, let's also take a look in the market, in Central Latin America. So this market is a little bit different. As you can see that the utility is very dominant. However, if you look into the other segments, you also still see a nicely steady annually growth of 30%. So this is really a future topic of the energy storage, and I'm sure it's another revenue stream for a lot of solar companies. Now, after we look up the data, let's also take a look at what energy storage can do for your customers, right? So these days, the technology enables, it's so advanced, it really supports multiple applications. Off-grid is where, batteries started. Then they moved to the grid inactive applications, such as, just for backup or self-supply, time of use, or demand reduction. And we're going to cover those applications in the next slides. So overall, what energy storage can do is certainly, provide you backup power, and also can save you electricity costs. We're going to explain how that's, possible. But also another thing is to maximize your PV production. So really, it makes sense, especially for your PV customers. Now, off-grid is pretty straightforward. You have solar, right? And then you have, battery-based inverter. It could be grid active or could be, just off-grid inverter. It connects to the battery, and then you have supplying the power to the home load. Usually people will also add a generator just in case if you have cloudy days, then you have a generator to support additional power that you need. Now, the off-grid used to be in terms of the percentage, much bigger than the grid inactive systems, but this has been changing in the last few years. So in the grid interactive applications, backup is still the the number one application. So if you look into the graphic here, what's different than off-grid is that now you do have a grid here, and as you can see that the inverter can take the power from the PV, feed back to grid during the day when there's excessive power. And when the grid goes off, then it will form its own island systems. So you have the PV to power or battery to power the load. Sometimes people will also, add a generator, just be a third energy source. Now, what's also getting more popular in certain areas is if you're subject to time of use, or if you have a high demand charge, the kW charge. If you look in your electrical bill, there's a space, if you're subject to the kW charge, you will see that amount. For example, like in New York State, the kW charge is very, very high. Now, how does, this application work is basically the hybrid inverter here is smart enough where it knows when to block the time for purchasing the grid power and when to, use the grid power or the PV power to charge the battery. Typically, if you need to use the grid power to charge the battery, it will happen when the tariff rate is low. Now, for commercial customers, that the kW charge is mainly, for commercial customers, and at this moment. And what it does is like the utility is going to, measure every 15 minutes the kW. And if you have a hybrid inverter and a battery, add another, smart control unit to it, then what's going to happen is before that 15 minutes interval come in, the control unit can turn on the energy storage and to reduce your kW charge. And for some area, that's savings significant. If you are living on Hawaii, Arizona, or in Caribbean, so you do have access to the power. However, either that the grid power is very, very expensive and the quality is very poor, or you don't have net metering. So basically, you cannot feed the PV power back to the grid at all. In that case, then you add a battery. Totally makes sense because then you can capture those excessive power during the day and then discharge the battery in the evening. And then you still can use the grid basically as a second source. If, for instance, in the evening, the battery has been discharged at a low percentage, then the grid can kick on and start, supplying the home and charge the battery. So those are the applications are commonly seen. Now, just a quick introduction of the company, what we do, who we are. So we are a lithium battery manufacturer based outside of Philly, about 35 minutes north of Philly. We have a 30,000 square foot facility where we R&D the product. We have our sales team as well as our logistic and technical support team here. We do also have logistics centers that in California and in Florida, they mainly to serve the customer in the West Coast as well as the customer down at South. We have about 35 megawatt installs worldwide. We also, are exclusive battery supplying for SEPTA, the PO Railway company. Now we focus on lithium phosphate technology, which we're gonna talk about that in later. So this is our manufacturing facility based in Shenzhen, China. It's ISO OSAS certified. It started producing, the battery since 2008. I used to primarily focus on the consumer product as well as automotive. And now we, starting to bring that technology now to the renewable energy space. Here are 3 products that we offer. The bigger one's 18.5, and then the 10, and then the 5. So it's really designed to be able to fit for small application up to medium size of commercial systems. Now, when we talk about the lithium technology, it's really important to emphasize the battery management systems. So inside of a lithium battery, you have the battery cells, and they are lined in serial and parallel to get to a certain voltage level or the capacity level. And then on top of that is the battery management systems. What it does, it has a lot of smart electronics inside that monitoring the voltage, the temperature, the current, and it's make sure that the battery not overcharge and discharge or short circuit or over circuit, as well as overheat or even low temperature. And also another important function is that some BMS does, some not, is this balancing. So it measures the voltage and then on a constant base to balancing the voltage, make sure the inside individual cell are operating at the same voltage level, and that is critical for longevity of the battery. And this is on the right hand, you see this is the LCD display on the eVolt units, where it gives you the voltage, the state of charge, as well as their in and output current. Here's some technical specification. I'm not going to go to the in depth. It basically tells you it's a 48 volts battery and capacity vary from 100 to 360. The lithium batteries always, because it has battery management systems, so it comes with a maximum charge and discharging current. So when you design systems, you will make sure that you're operating within the BMS, the threshold. And then the 5 and 10, you can stack 2. The eVolt, you can go up to 12. The eVolt also comes with LCD monitoring as well as the communication. So in terms of the communication, a little bit more in depth is the battery management systems. Usually they are self-managed, typically self-managed. There's some not. So you can hook up with different inverters, and then you will set up the parameters in inverter, make sure that they both work smoothly together. The other way is that you can also allow the communication. And that means that the battery will report the data to the inverter, such as voltage, temperature, and the current state of charge. So the eVolt allows both. You can do a it's called closed loop or open loop operation with an inverter. The eVolt has 250 amp breaker, and 510 is a smaller breaker. We do offer up to 10 years warranty. Here in Canada and US, it's 10 years. Outside of the country, we offer 5 and 10. So basically, offer lower price tag and allow clients that 1 to 10 years warranty, they can, add in that additional 5 years warranty. Just want to be more flexible with some clients. Now we're going to dive into the battery technology comparison here. So first, we're going to talk about different lithium technology that are commercially utilized. There are primarily 3 chemistries. One's a lithium ferro or lithium ion phosphate, or even some people call it LiFePO. So it's all talk about the same chemistry. And then you have also lithium ion or nickel manganese cobalt. The short term is NMC chemistry, and the other ones are lithium polymer LiFePO technology. Now, here's why the lithium ferrophosphate or LFP batteries are getting more popular for renewable energy sector. Is because it's safe. You don't have the cobalt like in the NMC battery. It's very good thermal stability. And it also can be fully recycled. And that thing is, it makes sense for renewable energy because that's what we're here for. We want the earth to be better. We don't want to pollute the earth. And it has also substantially more cycles, as you can see the number here, and also degrades slow. So if you degrade slow, that means that, the battery capacity is going to last longer, and the battery is eventually going to also last longer. In terms of the energy density, then the LiFePool and NMC are better. That's also why they are not, more used in consumer product like a phone or like automotive, because, automotive certainly chase for mileage, but for renewable energy application that I think, especially for the contractors who are going to put their chemistry in somebody's home, you want to make sure that's safe. That's why the LFP makes sense, and plus there's more cycles. So for long-term, through lifespans, the clients get more. Here, just a quick video that you can search on YouTube. You just type in LFP versus NMC nail test. Then you'll be able to see that when the nail drives through the cell, and that's going to create a short circuit, and you can see how the battery is going to react to the that test. You'll be very surprised at the NMC chemistry that exploded right away, and it's very hard to deal with that. And the LFP cell is, you see that's, gaining heat up, but it's eventually just smoke. So it's, pretty safe. When we talk about a battery's lifespan, there's always, three main factors. One is charging discharging rate. So typically we suggest that set up 0.5 C. That's, really good for the battery lifespan. The 0.5 C, and just give you an example, if for the LFP 10 is 200 amp hour, so 0.5 C is 100 amp. So that means charging discharging rate is 100 amp, and that you can set up in the BMS. And then another factor is the temperature, and this is a temperature behavior of LFP chemistry. As you can see that in the high temperature range, anywhere above the 0 degree and go up higher, looking like 50 Fahrenheit to 140 Fahrenheit. The capacity of the cells are pretty much very consistent. When it goes below, then the capacity will drop, and of course the lifespan also going to be shorter. So again, if you want to get the best performance, you want to keep in the temperature control room, and especially if you're in like northeast here, it gets really pretty cold in the winter. So put in your basement, it's a good place. And the third factor is the depth of discharge. Now that means how often you let the battery to be discharged. If you start on the blue here, so if you just set up 50% double discharge, then it really can go above 10,000 cycles. And if you let it set up at 80% of double discharge, then you can go above 6,000 cycles. And if you let every time fully discharge, from 100 to 0 and then back to 100 and then force back, that's really going to shorten the lifespan of the battery. So you look at, about 2,000 some cycles. And we guarantee 80% at 80%, 6,000 cycles. Now, also let's compare, the LFP chemistry with the traditional lead acid family. So you have the flat lead acid, AGM, and gel. Now, the one thing is about the capacity, how you read the capacity. So the lead acid usually, tell you it's 200 amp or 400 amp hour rated, right? So that's an example, 200 amp hour. So typically you really can get it about half. So the nameplate is not the actual capacity is usually 0.5, 50%. The LFP, the actual capacity is equal to the nameplate. So 200 amp hour, you really can get a 200 amp hour. And also the lead acid capacity is also can be, more impacted by the charging discharging rate and temperature and double discharge. Here's a graphic that shows you when you start to draw more power or higher amperage out of the battery, then how the capacity is going to change. with that lithium, as long as you stay within the BMS parameter, then for example, the 200 amp hour battery, if you discharge at 100 amps, it will last for 2 hours. So you can expect it 2 hours. With an other type of lead acid batteries, the capacity will drop. So you might expect to last for 2 hours. Of sudden, it may be only 30 minutes. So that has a big impact if you are, for instance, in the down in south and in summer, you want to turn your air condition, and that's gonna really make the battery last much shorter than you would like to. Here's a space comparison. So it's one of our customers' sites. He used to have the AGM batteries, and it's 48 volts, 250 amp hour, 6 kilowatt hour usable power, and this is the E-Volt. As you can see, that requires much less footprint and much, 3 times more capacity. Now we're going to spend a little bit of time on this comparison chart here. This is to show efficiency, the cycle life, as well as the total energy throughput, and then of course the cost per kilowatt hour. Because again, that's a true apple-to-apple comparison as the cost per kilowatt hour. Started with the LFP chemistry, so it has very good round-trip efficiency, so 98%. So you only have 2% loss. The other lithium family is a little bit more, so it's 5%, and flood and AGM is somewhere between 80 to 90%, depends on the manufacturer and some a little bit advanced technology. The nickel iron is pretty low, really only 65%. The cost here is just if you go website and search for the different battery chemistry and how much you're going to pay for it. And then here on the lifespan, so assume that all the batteries can be discharged every time at 80%. So by the way, the flood lead acid family, you still can discharge 80%. You can, but of course, it's you can see that the cycles really wouldn't last too long. That's why typically when you design lead acid, you set up a 50% DOD. But I would like to get an apple-to-apple comparison. That's why I set at 80%. For off-grid years, it means that if you do 1 cycle a day, so assume you are living in an off-grid home, and that you really need at minimum 1 cycle a day. In that cases, the LP can last 15, 16 years, and the other lithium chemistry can last about 4 to 7 years. The flooded lead acid is really low, 1 or 2 years. The nickel iron is very good; it can last 22 years. But as you can see, the cost is also higher, the highest among all the chemistries. Now, the energy throughput, how is this number comes? Basically, so it's a 10 kilowatt hour battery, and you multiply 98%, basically efficiency, and then multiplying the 6,000 cycles. That's how you get this total energy throughput in that expected lifespan. So for LFP, it's a 47 megawatt hour. Nickel iron's number in the second place, it's around 41.6 megawatt hour. And the others are certainly much less. Now, then you use the out-of-pocket cost to divide it, the energy throughput, then you will get the cost per kilowatt hour, and the LFP has lowest cost per kilowatt hour is 14 cents, and the nickel iron is on the second place. So nickel iron is mainly used in a large application, some utility scale projects. For homes, I don't see there's too much application there. So it's mainly dominated by the lithium and lead acid batteries. And then in terms of the safety, that the LFP and nickel iron are very safe. Other lithium chemistry, we talk about, the summer runaway or fire risk and flooded AGM, lead acid or AGM that has a potential release harmful gas. And the lithium, of course, you don't need any maintenance. So does AGM. The flooded and nickel iron does require maintenance. And that's also a little bit challenging for homeowner, even, business owners to keep an eye on that. So a quick summary of LFP Technology Advantage, much safer. It has high energy throughput, lasts longer, and it has lowest energy cost. Now we're going to go to the inverter section on basically, how to integrate the energy storage to your existing or new PV array. So there are two types of configuration when you design the systems. One's called AC coupled, and the other is a DC coupled solution. In an AC coupled solution, then you have already, a PV inverter there. It connects to the solar panel, and then you have the hybrid inverter, or you call it inverter charger, that is connect to the PV inverter as well as to the main panel. It also connects to the battery. Now, so the battery is really, being charged by the hybrid inverter, either, take the power from the PV or from the grid. So that's why it's called AC coupled. So it's on the, AC side. The AC coupled solution is mainly used when you look to retrofit to existing PV array, especially if you have microinverter or optimizer that's almost impossible for you to go back, take those off. And AC coupled, works well. Now, the AC coupled, as you can see, now you have two conversions. You have DC to AC, then you have AC to DC, right? So that certainly has some efficiency loss, somewhere between 5 to 10%, depends on the manufacturer and depends on, the technology as well. And DC coupled solution is that you do not have a PV inverter. Instead, you have a solar charge controller. So this charge controller can be an external device, a separate device, or can be also, in one unit combined with the hybrid inverter. The charge controller will take the PV and charge the battery. So it's DC to DC. The hybrid inverter connect to, AC backup load panel if you need it, and to the main panel. It's more popular for new installation, and it's more efficient because, again, you don't have two-step conversion, and it doesn't require additional PV inverter, so you save cost on that. And in general, I would say DC coupled system works just more smoothly because you don't need the PV inverter and the hybrid inverter like an AC coupled solution to coordinate, and they can do the frequency shift smoothly. Here's just a list of the inverter that we work with, and here I want to talk about the open loop and closed loop that I mentioned earlier. So the open loop is that you don't have a communication between the inverter and the battery, so you basically just set up the parameters in inverter. And the closed loop is that you have a communication. So we are establishing communication with Schneider, SMA, Stork, and Victor. After that's been completed, then you just basically, the inverter will report the data to the battery will report inverter to the inverter, and then it does not need a manual set for that. So I'm going to talk about two types of hybrid inverters that on the market now. So the new ones that you have from the charge controller, the inverter, all in one unit, and this is a cookie cutter solution that we offer with a 12 kW inverter and eVolt 18.5. You can, of course, expand the systems In terms of storage capacity, you can go from 10 to 2022. It's very efficient, 93% round trip efficiency. That's which also very important when you look into the energy storage solution. So basically, it's from PV to the battery and then from battery to the load. So you want to figure out that efficiency. Now we know that solar production is pretty prestigious, and we want to precious. So we want to keep those energy. We don't want to lose them. It has also Gen start, so it allows you to integrate generator if you wish to. You can also do AC and DC coupling. So now we see also the inverter, hybrid inverter, so it started getting also more flexible, allow you to DC and AC couple to your array. It supports off-grid time of use, self-supplying, backup, grid export, all those applications that we talked before. Some basic technical specification here is that it's in full capacity 12 kW. When the grid goes off, if you operate on solar and the battery is a 9 kW, when during the day, when your battery is fully charged and your home's not consume too much power, then the excess PV production will be passed through directly to the grid, and that basically increases efficiency. So you don't have to go through the battery, and that's also better for the battery's lifespan. In terms of storage capacity, we talk about you can do 10, 18.5, and then you can stack them. It has 20 kW surge power for 5 seconds. That allows you to put some, heavy-duty appliance like AC unit. Now the grid transfer time is very quick. So that means if the grid goes off, now the hybrid inverter will start, create island system, disconnect from grid, and it will bring on, within 4 milliseconds. Very, very quick. It basically meets the UPS standard uninterrupted power supply. Typically requires need to be less than 10 milliseconds. It's compatible with the N-phase microinverter, AC module, solar age. You can do DC coupling. There's a 4 PV input, 4 strings. You can do DC coupling up to 13 kW, or you can use the AC input to AC couple to the system up to 7.6 per inverter, or you can do even both together. And it means you can, for instance, if you're 13 kW, you can do 10 kW through the DC input and the 3 kW through the AC input, and that just increase your array size. Now you can stack 3 of them, go up to 36 kW, and the next year we'll be also able to support 3-phase. So you will each leg put a 1 inverter, form a 3-phase, and eventually to the 72 kW. So that's a solution which you have the inverter and charge controller distribution box all in one unit, very similar like a traditional PV string inverter, just with some more, you have the battery terminal, and plus that you have you can connect to the backup load panel as well as generator input. Now, Schneider is very well known, and they've been on the market for many, many years. And offers very high quality products. You have the differences, and you have the charge controller, you have the hybrid inverter, and then you have also distribution panel where you allow you to hook up multiple inverters. It also supports all applications that we talked before. You can do DC and AC coupling. When you do DC couple, then you get a charge controller. If you have already existing PV inverter, it could be string inverter or microinverter, then you just get the hybrid inverter and then the distribution panel. So you do not need charge controller for AC coupled systems. It allows also you to stack, and you can also form 3-phase systems. You can also get a Gen start set as well. And this is a system with 2 of the XW6848 and 4 of the eVolt unit. Some also basic technical information here of two type 5.5 and 6.8. They also allow you to surge very nicely up to 12 kW for 60 seconds. Storage capacity, 10 to 22 kilowatt hour. It has 60 amps auto transfer relay. The switch time is 8 milliseconds, also very quick. It supports, a lot of different PV inverters such as N-phase, SunPower AC module, solar age, SMA, 4 use 10 kW above model. You can also stack maximum 4 in one phase, in single phase or split phase, or you can form 3 phase and use the same, one inverter in each leg. You can do 3, 6, or 9. Now, if you're in an area that you are still within, NEC 2014 code, which will requires the string level rapid shutdown, then the both inverters I mentioned, they work with a Midnite. So you have, basically a transmit and receiver, and the receiver is connected to each string, and if fireman coming has to shut the system off and just need to push the rapid shutdown devices, and then each receiver gets the information from the transmitter, then the strings will disconnect, and then the fireman can go to the roof. Now, if you're, I know that more and more states are adopting the 2017 NEC code, and in that case, you will need module level rapid shutdown. So the Tigo offers TS4-4R smart module rapid shutdown devices that you can connect, connect to each solar panels, and that will fulfill your module level rapid shutdown requirements. So that's about my presentation. So that's what we cover today. Here, just, if you are interested in our solution or, get more technical support, you're welcome to join us, become an authorized installer or dealers. We have application form, one page you fill out, and we look over, see if you have already installed a PV system before, and then we'll give you product sales training, and if you need help on design first a few systems, we'll be more than happy to support you. I also want to mention we have another webinar for next week. It's more on the technical. It's more focused on, design and install the lithium storage systems. It's going to go more in depth. When you design, how you're going to make sure that the inverter and the BMS is going to work smoothly together, as well as how to install the lithium batteries, and as well as how to program the inverters based on your battery bank size and model that you choose. So it's going to be next Wednesday, November 20th, 1 p.m. Here's the webinar link. So when I send you after we send you the presentation slide, then you can go ahead and register. Also quickly mention about a holiday promotion we have. It's time of the year to celebrate, but of course, that we also in the past few months down in South in the Caribbean, we had a large storm or mini storms, and also now the windstorm is also coming. So we want to offer this special promotion. So basically, you can get up to $500 discount, plus also free shipping. Depends on which model you choose. When you place order, you can use the promo code GoGreen11. So that's my contact information here. Now I'm gonna take a look, see if you have posted questions here. I do see there's a lot of questions, which is good. So what I'm gonna do, I'm gonna go over those questions. One from John Hansen mentioned about if we offer a system over 2 megawatt hour. So we do not offer that sizes for us. The sweet spot is, anywhere from 5 to 222 kilowatt hour. Then I have a question from No Heng. I hope I pronounced that right. If I, didn't, please forgive me. It's asking, how can I get the cost of Fortress Power lithium batteries? That's a very good question. So we have in some countries and some region, we have a distributor there, so you can get from our distribution partner. So you're welcome to email me. And if in the region we do not have distribution partner, then we can also, look into if you have enough solar experience, if we can certify you, and then you can buy direct. But again, first I prefer to go through our, existing distribution network. And I have a question from Glenn. Do the Fortress battery qualify for Made in USA projects? We are not qualified for Made in USA. However, now we've been also working with a lot of government projects. Of course, for those projects, you prefer Made in USA, but we don't have too many, LFP batteries are truly Made in USA because the technologies are in Asia, especially for this type of technologies are mainly from China. So you can make, if you work on some government contract, you can make that to, the government entities, and they will most likely approve you, and you can use certain materials that from outside of U.S. To the Fortress, then I have a question from Federico asking, do you accept register installed abroad USA, in Panama or Colombia or Spain? Sure, yes, we do. Federico, we can also, send you the form so you can fill it out. And we just need to get some basic information about your business, your activities, and your, your territory. And I have a question from Ravi. Clarification required. You said 0.5 C charge rate. Does this mean maximum a 2-hour to full battery charge if needed? That's correct. Yes. So a 200 amp hour, like the LFP 10, that you can set up 100 amp discharge and will last for 2 hours. Yeah, that's the C rating. And I have a question from GE, price of the batteries. So I would encourage that you let us know where you're located. If we have a distribution partner, we will have them to quote you because we don't step on the toes of our partners. And if we do not, and we can serve you directly, we can qualify you, and then you will get a price for that. Another question for Emiliano. Thank you from Honduras. We will contact you. Thank you for joining us. Certainly feel free to contact us. And then I have a question from Richard. Can my company rep Fortress Power in Tri-State? Yes, sure. So I have your email here. I can send you in a separate email for that, and we can discuss about it. So those are the questions I have. Any more questions? Oh, okay. I did get from G asking, can we white label your battery? We can talk about that, but that's, certainly that's a completely different. We need, to understand more about your need and see if it makes sense for both of us. I've also a question from Janelle. Can we get copies of the presentation? Yes, absolutely. You will get after the presentation tomorrow. We will send out the slides, presentation slides, and including, authorized installer form. And if any of you are interested, feel free to fill out and send back to us. Let's make the Earth to be a much better place for next generations. And PV plus storage just totally makes sense. And this is the future. Okay. Everyone, appreciate you joining the webinar. I hope that some information are helpful for you. And if you have any further questions, feel free to contact me or email us or even call us. There's a phone number there. And yeah, look forward to working with you.